In this lecture, we are going to solve this problem called find if word exists. So we are given a 2D board and we have to find if a given word exists in the board or not. So here the different letters, they can be represented as different element in 2D matrix, and we have to find if C is there or not. I can see that C, this is there. Here we have S, then E, and then E. So visually I can see that the answer exists, but how can I solve this problem using code? So firstly, what we have to do is we have to traverse through the whole matrix, and for each point we will try to do the word search from that particular cell, and if we are able to find the word, then we will return true. If we are not able to find any word and we have traversed this complete matrix, then we will return false. Okay, so from each cell we have to do the word match for finding if the particular word exists or not. If I do word match from this S, I won't be able to find SEE because it doesn't have E, which is the next letter, as its next immediate neighbor. From here I can do the word search, and I can see that SEE will be found from here. Okay, so how will I do the word matching? So suppose I have this word, then how will I match these words? How will I do this? So for this, we will be doing DFS. So what we will be doing is that we will be taking a visited set, and that is going to help us keep track of all the letters that we have already visited. So we do not reuse them. For example, if I visit this S, and if I visit this E, then I cannot retake this E, or I cannot again take this S, okay, because they are already taken. So for example, if this S is taken and this E is taken, then we can only move in one direction. We cannot move back, okay? We cannot have like S is taken one, then E is taken, then S is again taken. Once it is the word is taken, we cannot use it more than once, okay? So this is going to be our solution over here. And now when we'll be doing this, what we will be doing is that we will keep a variable called as matched, and that is going to denote how many letters of the target word we have matched. For example, in the target word C, there are total of 3 letters. Okay, so if we are able to match 3 letters one after another, then we will say that yes, we have found the solution. For example, here we are at S. We can say we have matched one word, which is S. Now we will look for the next one, which is E. So when we move to the next one, we can see that yes, we have again found the E letter. So here the total number of matched is 2, and then we will look for the next letter, which is again E. So after we found this E, we can say that we have found total of 3 words, and 3 is the length of the target word, meaning we have found all the words. Okay, or and what is going to happen? So suppose here we can go on another path as well. For example, I'll take the S, then I'll go to this E, and from here I can see that I cannot get another E. Okay, so this path is not possible for me to get the solution. So I'll need to backtrack. Okay, so I'll need to backtrack. So every time we backtrack, what we will do, we will since when we are visiting the since we are starting from S and then we are visiting the E, we have added S and E to our visited set because they are visited. But what will happen is once we will backtrack, we will remove this E from the visited set. So S is the only one which is visited. E is not visited. Okay, E is unvisited now because we are not exploring this path anymore, and we keep exploring the other path, which is this one. So now this time we will add E to our visited, and so on and so forth. We will be exploring this solution. Okay, so initially you can see that we have traversed through all of these, and since A cannot form the word C, therefore we move to the next one, which is B, C, so on and so forth, and until we get to S. Now we try to form the word. Okay, so we have found S. Okay, therefore we are adding it to the visited set, and then we mark matched as 1 because we have matched one word. Okay, and then we will start looking for the other words which are E and E, but sadly there are no any other E next to this S. Okay, so we will not be able to form any solution. Now we will move forward to other elements, and finally we will get to this one S. So again we will add this to the visited set, and we will mark mesh to be 1 because we have meshed one word which is S. Now we have to find E and E. Okay, so we have E available on two different positions, right above and right below. So if I go above, then I have now this E. So now the total number of mesh words is 2, and I'm adding this E to my visited set. Okay, and now the mesh is 2, but what will happen again? Now there is nowhere to go from this E since we do not have another E. So we need to backtrack because we cannot form solution from here. From E, we cannot go to another E since we cannot find this third letter. We will backtrack, and what we will do, since we are backtracking to our previous path, therefore we will remove E from visited. E is marked as unvisited. So again, the visited is S only, and the meshed is 1 instead of 2 because we have only meshed one letter and we have only visited S. E is marked as unvisited because now we are exploring other path. Okay. So now in this another path, we have found this E. So now we have S and E in the visited. And since we have found two letters, we will update our mesh to 2. Now again we are able to find the another E. We had to find E right after we have found the first E. Okay, so this time we will add it to the visited. Okay, and in the visited we have all the letters, and meshed it is updated to 3, which is the length of the total visited uh, characters. Okay, so the currently matched characters, sorry, this is the currently matched character, which is 3. So currently matched characters, there are total 3 characters which are matched, and 3 is also the length of the target word. That means we have found all the characters in the target word, or you can say that we have found the word. Therefore, we have solved this problem. Okay, so now we are going to solve the same problem in code. So let's go to the Leetcode. Here it is the same problem, and let's get to the solution. So firstly, let's define the rows and columns, which are basically the length of the board and the length of the first row of the board. Okay, and we are going to traverse for each cell. So for I in range rows and for J in range columns, what we are going to do is basically we are going to perform the word match, and let's just call this as DFS, or we can call it as word match. Okay, so we will do the word match at this one particular uh, cell. Okay, so we will pass the board because that would be needed for traversing, and then we will pass the current position, which is I comma j. This will be used to represent our cell. Okay, and we will also pass the visited set so that we can keep track of all the different cells that we are visiting so that we do not revisit them. So visited is a set, and which is what we are passing, and this method will return either true or false. It will return true if we found the word, and it will return false if it is not able to found. So we will set found equals to self dot word match, and if we are able to found, then return true. Otherwise, if we traverse through the whole of my board and we were not able to found anything, we will return false. Okay, and let's just also define this word match method. Okay, so we are going to take the board, and then we are going to take the cell, or you can say the node, and visit it set. Okay, so what we are going to do is if the cell in visited, then we are going to return false. Okay, because we cannot revisit a cell, okay, once it is visited. And what we are going to do, we are going to mark the current cell as visited by adding it to the cell. Okay, there are going to be some more checks that we have to mark. For example, we have to do one more thing, which is keep track of the totally matched words, right? So here we have to take another variable which is matched, and it will represent how many words we were able to match, right? So we will also pass this matched word in the word match method. Okay, so one thing that we know is that if this matched variable, if this matched variable has a length, if this is equals to the length of the target word, then that means we have found our solution, right? So we will return true. So that means we will also have to pass the word to this method, okay? Because that is what we will be using to compare the current cell with. Now, what is another condition in which it will be false? It will be false if the current character that we are on, if current character it is out of bounds. So that is one thing that we have to check. So, okay, so if x is less than 0 or x is greater than equals to the length of board, or y is less than 0 or y is greater than equals to length of board 0, if it is out of bounds, then we will return false, because we cannot form a solution by going out of the board. That is not a possibility, right? We cannot form the solution from a cell which is already visited, so that is also not a possibility. So here also we have false. And one more thing that we have to do is, if the current cell that we are on, if it doesn't match the current letter of the target word we are trying to matching, then we need to return false. So if matched is actually representing the index of the word that we are trying to match, for example, so this can be the word matched is actually the letter that we are looking for. Okay, so if it is not equals to the current uh, element that we are on, that we get from board xy, in that case also we have to return false. Okay, so these are some of the conditions. We will return true if we have matched all the letters. Okay, so if match equals to the length of word, then we will return true. Otherwise, if it is out of bounds, then we cannot form a solution from a cell which is out of the bounds, meaning out of the board. We cannot form a solution from a cell which is not visited, which is already visited. So we cannot take it once again. And our solution will not be formed if the current cell we are on is not matching with the word that we want, is not matching with the alphabet that we are trying to match. And the alphabet we are trying to match is the word of matched, where matched represent the current index of the target word that we are looking for. Okay, and if all of this happens, then we are marking if all of these conditions are for true, meaning if none of these conditions is false and base conditions are met, then that means we have found the current word, and then we will try to find the next words. Okay, so for that, how we can do that? We can either move left, right, top, or bottom, right? So we will ask the same method to explore in all these different direction. Okay, so the board will be there like that. We will have x and y minus 1, which is for the left. So this method will return true if there is a word that is matching, that is on the left. So I'll mark it as found left. Okay, So here, let me, so this is a tuple which is representing the cell, and this is going to be matched +1 since the current cell is matching. If it wasn't matching, it would have returned false, but it is matching. That is why we are incrementing the matched by 1. Okay. And we are then passing the same word and the visited. Okay. So this is for the left. Similarly, there are other 3 directions also, which is for the right, and for the right we have to increment the y, and then we have the top, and then we also have the bottom. For the top, the x needs to be decremented, y will remain the same, and for the bottom, x needs to be incremented and y will again remain the same. Okay, so these are the 4 different possibilities, and after these function calls are completed, okay, so that means we have hit the, it means that we have hit the end, right? So what we will do, so when we are exploring other possibility, we have to first backtrack, and right, and when we are backtracking we have to remove the current cell from our visited array. Okay, because we are exploring other possibilities. So I will remove the cell from our visited set. Okay, and then finally we have to find if we were able to found either through left, through right, through top or bottom, right? So we will return found left plus found left or found right or found top or found bottom. Okay, so this is the backtracking step. This is the backtracking step that we need to take, and these are our conditions. So if we have matched all the letters of the word, then we have to return true, and we have to these are the different conditions when we will not be able to match the word. But if the current cell, it is out of bounds, it is out of the board. Okay, and if the current cell is already visited, then also we won't be able to form the solution, therefore we are again returning false. And if the current cell is not matching the word that we want to match, then also we will return false, right? And only when all of these conditions are checked, we can mark the current node as visited, and then we can start looking for the next letter of the word. Okay, so we increment the matched, and then in all the 4 different direction, which is left, right, top and bottom, we are starting to explore the solution for the rest of the characters of the target word. Okay, and when we are done exploring all these 4 different directions, we want to backtrack, right? Before going on any other path, we want to backtrack. So when we are backtracking, we have to mark the previously visited cell as unvisited. Okay, so we are removing it from the cell. And in the end, we are just returning if we were able to found from the left or from the right, from the top or the bottom. If any of these direction we were able to find the word, then we have to return that. Okay, so this was the solution, and let's just try to run it first. Okay, so it is as abstract, and let's submit our solution. Okay, so our solution is accepted. So this was it.